Welcome to Brain Vision.
Suppose a sound wave traveling through the top layer of the Earth is reflected by discontinuity under the Earth's surface. The reflected pulse reduces the surface after 0.08 seconds after the sound emission. We would like to determine the distance from the surface to discontinuity and to describe the impedance to sound that the discontinuity has. We notice that the sound travels at about 3000 meter per second through the top layer of the Earth, and the reflected pulse is inverted and has an amplitude less than that of the pulse that entered. Suppose the distance between the surface and the discontinuity, we call this a y. This means that the sound emitted by the explosion will travel a distance y until it hits the discontinuity, then reflect back and travel another distance y to the surface. If this travel will take a time t, then we can write equation for y will be 1 over 2 vs, this is for sound speed, times t. We call this equation 1. Then we substitute a 3000 meter per second for Vs in this equation and 0.08 second for t. Then we write y is equal to 1 over 2 3000 times 0.08 seconds. This gives us y to be 120. And the impedance of the discontinuity is larger than the impedance of the layer above it. We can say that because the reflected pulse is inverted, so our y is 120 meter.